Okay, the warm-up question says, if you perform an experiment and find a classmate's height to be 173 centimeters, is this a reasonable value? And maybe you know the metric system well enough to give me a yes or no, and maybe you don't. So for some of you, you might need to answer number 2 first, because if you have no concept of how big 173 centimeters is, we need to put it in units you do know. That's what number 2 asks you to do. So let's go ahead and answer number 2 first, and then we can answer number 1, although I did hear a couple of you answer number 1. That's okay. Number 2 says, given that 1 inch is 2.54 centimeters, convert this to feet and inches. And so I'm asking you to do a conversion from 173 centimeters into feet and inches. And I'm going to work this out by hand. And we're going to be using the same method that you used or will be using in your chemistry classes, because I know some of you are taking chemistry this year and haven't yet completed that course. And so we're going to use something called dimensional analysis to convert from one unit to another. I forgot my unit there. So I'm going to take 173 centimeters, and I can hear some of you going, because you're going to have flashbacks in just a second. But we're going to use our conversion factor. And in the question I told you that 1 inch is equal to 2.54 centimeters. Okay, and so we're going to use this as a conversion factor. And what I mean by that is we're going to multiply by a fraction, and I'm going to put my 1 inch here, and I'm going to put my 2.54 centimeters here. And I'm doing this because, first of all, these two things are equivalent. They're the same. They're just different units, but they're the same value of length. Okay, but I'm setting this up so that I can cancel these units, because as you guys are well aware, if you divide by something, it's going to cancel. Like if you multiply and divide both the top and the bottom of a fraction by the same number, it's going to cancel. But the same thing is true for units. I can cancel my units this way. And in chemistry, maybe you wrote it like this, 173 times 1 over 2.54. But oftentimes, your chemistry teachers will write it like this. So if that didn't quite look familiar, that probably does. Okay, it's the same thing. We are multiplying by 1 over 2.54. Well, I'm not going to waste my time multiplying by 1. I'm simply going to divide by 2.54. So let's go ahead and turn on my fancy calculator. Okay, and we're going to do 173 divided by 2.54, enter, and we get this. Okay, 68.1102. Okay, so that's going to be my answer in units of inches. Now, the question didn't ask for inches, it asked for feet and inches. Okay, so I need to know how many feet this is. Okay, I know that there are 12 inches in a foot, so if I simply divide this value by 12, it'll tell me how many whole numbers of feet that I have. I have 5 whole feet and then some number of inches. Okay, and so I would have 5 feet. 5 feet is 60 inches, so I have this much left over. I'm just going to call it 5 foot 8 inches. I'm not going to worry about 8.1102. Okay, but if you are 173 centimeters tall, you are 5 foot 8. So going back to number 1, is that a reasonable value for someone's height? Yes. If you didn't know that before, you know it now. But hopefully you have some working knowledge of the metric system. And if not, hopefully doing conversions like that will at least help you to visualize how much 173 centimeters is. Okay, so we're going to be doing unit conversions, and we do almost exclusively use the metric system. So if it's not something you're familiar with, you're going to have to get there. So let's go ahead and start with our notes today on unit conversions. First of all, you want to report your measurements in units that make sense. Last week on Friday, you guys did a lab where you were breaking wooden rods like this, and part of what you had to record was the force, which of course you just recorded, but the other thing was the radius. Would it have made sense for me to record the radius of this rod in kilometers? No, because that would be a ridiculously small number. Okay, and so report your units and answers in units that make sense. And you might have to do conversions to make that happen. Okay, so if I asked you to measure the distance from the school to your house, what would be an appropriate unit to use? Kilometers. I also heard miles. Yes, miles is what we typically use, but if we're using the metric system, we want to go ahead and go with kilometers. That would be the appropriate unit for us to use. Let's go ahead and do a conversion from meters to kilometers. It says, if my house is 8,735 meters away from school, how many kilometers away is it? And this should be something you guys know from like middle school math, or middle school science rather, but again, it may have been a little while, so let's go ahead and remind ourselves. Now, first things first, I have a table up here with a bunch of conversion factors, and I've outlined the ones in red that we use most frequently, and kilo is definitely one that we use quite a bit. If you look over here to the last column, it tells us that kilo, a kilometer, or a kilogram, or kilo anything, is the base unit times 10 to the third. So it's 1,000 base units. So there are 1,000 meters in a kilometer, or 10 to the third meters in a kilometer. And so I'm going to use that as a conversion factor, just like I did in the warm-up. And when you set up a conversion factor, you're always setting it up so that this unit cancels. So since I have meters on top, I need meters on bottom. Okay, but these two values are equivalent to one another. 1 kilometer is 1,000 meters. So I'm not changing the length here. I'm just changing the unit that I'm reporting my length to. And so 8,735 times 1, I'm not going to bother typing that, divided by 1,000 is going to give me 8.735 kilometers. Because again, I canceled my units of meters and was left then with kilometers. Okay, so just basic conversions, you need to be able to do them. If you took chemistry, this should look very familiar because you did long conversions from grams of water to moles of water to moles of something else to whatever you were looking for. So you, again, should have kind of flashbacks of the dimensional analysis that you had to do in chemistry. If you haven't taken it yet, have fun whenever you get to that later on. But hopefully it'll be a little bit easier since we're going over it now. All right, so let's look at just a tip here. Here's another example, if I were you, another one to write down on my paper. A remote control car uses a low band VHF of 49 megahertz. Convert this to hertz. I don't care if you have any clue what any of those words mean. I don't know. It doesn't matter if you know what a hertz is. You can still do this conversion because look, if you see a prefix in front of the unit like this M, it's in the table. Capital M is mega. Mega means 10 to the 6th. Okay, if it's a lowercase m, that's different. That matters. That's milli, different thing. Okay, so this is megahertz. If you see a prefix, replace it with the corresponding power of 10. So 49 megahertz is 49 times 10 to the 6th hertz. That's what that is. Now, that's not the appropriate way to write scientific notation because my coefficient when I write in scientific notation should be between 1 and 10. So I need to write this instead as 4.9 times 10 to the 7th. So I just moved my decimal over 1 and added that exponent on to account for that. But that would better be written as 4.9 times 10 to the 7th hertz. Okay, so you can just go straight to the table. And by the way, a table similar to this is on your AP Physics 1 formula charts, which hopefully you picked up last week from the front table, but if not, there are still some up there and you can go get it after I'm done talking through today's notes. All right, so that is example number 2, I guess. So let's keep going through this. Anybody know what this standard SI unit for mass is? It is a kilogram. It's not a gram, surprisingly. It's a kilogram. Okay, kilogram is our SI unit for mass. If I asked you to measure a single grain of rice, do you think kilograms would be an appropriate unit? No, it's really big, or at least compared to rice. Okay, grams, milligrams, probably even better, would make the most sense. So let me show you why we wouldn't want to use kilograms. If the actual grain of rice is 0.021 grams, and I'm pretty sure I Googled that last year, so I think that's pretty accurate. Convert this to kilograms. Well, let's see why we wouldn't want to use kilograms. We're going to use our conversion factor. There are 1,000 grams in a kilogram. Again, I'm setting this up so that what's up here on top cancels down at the bottom. And that means I'm dividing the number now because the number's down here. There are 1,000 grams and 1 kilogram. And when I do that, I get this, 0.000021. Okay, that's why we wouldn't measure rice in kilograms if I'm looking at a single grain of rice, because it's such a small number. That's a lot of zeros to write. Okay, again, when you're writing this setup this way, it's the same thing as this if you'd prefer to write it as multiplying by a fraction instead of the little thing that looks like a plus sign, you can. It's the same thing. But again, you're setting it up, this conversion factor, so that you're able to cancel these units. Grams on top, grams on bottom. Same thing here, and we get this. Now this is a really long number to have to write out. It'd be shorter if I was to put it in scientific notation. And if I was to put it in scientific notation, it would look like this. 2.1 times 10 to the -5th kilograms. By the way, your calculator will automatically put some of your answers in scientific notation. If they're really big or really small, it'll do it with an E, like what you see on my screen. And this calculator does that too. I know this is a picture from a TI-84, but the Inspire also does that notation. So if you see something that looks like this, 2.1 E -5, that is 2.1 times 10 to the exponent -5. So times 10 to the -5th power, same thing. So if you're not super familiar with scientific notation in the calculator, you need to get there so that you can read and interpret these answers and also type them in. All right, let's try some more practice with dimensional analysis. If Tom is 6 foot 1 inches tall, how tall is he in centimeters? This is similar to our warm-up, except we're going to go the other direction. Okay, step 1, I'm going to convert feet to inches. So Tom is 6 foot 1, which means he's 6 feet and then a little bit more, but I'm going to worry about the feet first. He's 6 feet tall. Okay, again, the number you're given in the question starts here in the top. Okay, I know that there are 12 inches in a foot, and I'm going to set that up so that my feet cancel. That's how I know where to put the 12 inches versus the 1 foot. Okay, 12 times 6 is 72 inches. Okay, so, but Tom's not 72 inches tall because Tom's not 6 feet, he's 6 foot 1. So I need to add that extra inch back in now. So instead of 72, I'm going to go 73 inches, and now we're going to convert it to centimeters. Okay, so let's go ahead and do this conversion. There are 2.54 centimeters in 1 inch. Where should I put the 2.54? Top or bottom? Top, because I need the 1 inch on the bottom so that it cancels. Okay, so now I've canceled my inches. This becomes a multiplication problem. I'm dividing by 1. I don't really need to type that. 73 times 2.54 is 185.42 centimeters. Okay, so again, if you've already taken chemistry, you're probably thinking this is pretty straightforward, but if you haven't, this might be a new way of solving problems. Let's try some that are more fun or weird. I don't know, whichever word you want to use. These numbers are accurate as of last year. I have not checked to see his updated net worth, but let's go with it. Jeff Bezos' net worth is $158.1 billion US. If he was to spend $1,000 per minute buying NFTs of cats without sleeping, how many years would it take him to spend his entire fortune? I was really bored when I wrote this question, but it's fun. All right, so, or silly, or crazy, I guess, if you look at the answer. So what we're going to do is we're going to start with the number in the question, 158.1 billion, which, by the way, I'm going to write in scientific notation as 1.581 times 10 to the 11th. So I'm going to start with that. That's the number I'm trying to convert. Okay, and I need to cancel US dollars. Ultimately, I need to solve for years, which is weird to convert dollars to years, but I actually have a conversion factor in the question. He spends $1,000 US dollars per minute. So I can put my $1,000 US dollars down here and my 1 minute up here. And I can cancel my US dollars, and now I've got minutes. Okay, but I don't want to know how many minutes it takes him. I want to know how many years. And maybe you know how many minutes are in a year if you've seen Rent and you remember that song. But I'm going to go step by step. I know that there are 60 minutes in an hour. I know that there are 24 hours in a day. And accounting for leap year, I know there are 365.25 days in a year. Okay, and so I can cancel all my units, and now I have a problem that I can solve. Now your options when you're solving a problem using dimensional analysis like this is either to multiply the entire numerator and then go and multiply the entire denominator and then divide, or go left to right. I personally prefer left to right, but it is entirely up to you. So for me, I would type in my calculator 1.581E11, because I like to use that button in the calculator, divided by 1,000. I'm not going to mess with times 1. Divided by 60, divided by 24, divided by 365.25. If it's on the bottom, I divide. If it's on the top, I multiply, but I go left to right. It gives you the same answer whether you choose to do whole top divided by whole bottom or left to right. If you type that in, you will get 300.6 years. So it would take Jeff Bezos over 300 years if he spent $1,000 a minute and didn't sleep to buy. That's how long it would take him to spend all of his money on NFTs of cats. Okay, so pretty useless in terms of like knowledge, but you never know. But you do need to know the process. Okay, so let's do another crazy one. I went the same direction. Elon Musk's net worth as of last year was $262.9 billion US if he decides to gift his entire fortune to the citizens of the Houston metro area. That's all of us. How much money would each of us receive? The population of Houston metro is 7.12 million, at least again as of last year. I should probably double check my numbers now. Okay. So first of all, I'm going to put these really big numbers in scientific notation. So that 262.9 billion becomes 2.629 times 10 to the 11th. And my population of Houston, 7.12 million, is 7.12 times 10 to the 6th. And if I want to do this is just a simple division problem. How much money would each person receive? We're going to take that number, divide it by the number of people, and we find that each Houstonian would get $36,924. So Elon Musk had enough to give basically every person in Houston $37,000. I don't think he's going to do it though, so don't count on that. All right, but again, illustration of how big a billion is, but also just some practice with scientific notation and doing unit conversions and being kind of silly at the same time. All right, so whenever you take a look at a math problem in physics, you're going to want to start by taking a look at your AP Physics 1 formula chart. I took a screenshot of at least the top portion of it. It has a whole bunch of equations on it, and yes, you will see each of these at some point this year. But it has a list of formulas. It actually keeps going past here. I just cut it off because it didn't fit. And it has a list of variables and what they mean. So you can see over here what variable matches up with the equation that you're looking for. But when you approach any calculation problem, you're going to look at the data or observations on the question and locate the variables on the equation sheet. If you're reading a question and you're like, okay, they just gave me acceleration, they just gave me time, they gave me velocity, whatever. Start finding those things and then look for the equations that have those variables in them and look and ask yourself, how can I get where I need to go? If I'm trying to solve for, final position, how do I get there? And see if the equations can take you there. But you need to start by identifying the information you've been given and looking at the formulas on the equation sheet. So again, oftentimes the equation that you need is on that sheet, but sometimes you're not solving for the variable it's set up to solve for. Okay, so sometimes instead of solving for, the first one is, I think starts with V, or V naught, I can't remember. Hold on, let me pull the equation sheet up. So the first equation on here is V equals V naught plus A times T. And if I'm looking at that, maybe I don't want to solve for V. Maybe I'm supposed to solve for A. Okay? But the equation's there. You would just need to rearrange it and manipulate it to solve for the variable that you need. Other times, the equation's not even on this sheet. You have to use multiple equations to get there, or derive a new equation that's not even on here by substituting one equation into another one. You're going to see that more later on. We're not going to do that today. But you will have to derive equations based on the information on this sheet. Let's look at an example problem. And again, if I were you, I might want to copy this down so I have it to look at later. It says a car is traveling at a constant 35 meters per second. If it started at a position of 5 meters, what is its final position after 7 seconds? I'm aware we haven't talked about any of this stuff, although you should know some of these terms after looking at the definitions tasks. But we can still label the stuff we're given. I know, looking at this question, that I'm given 3 pieces of information. I'm given a velocity. It says a car is traveling 35 meters per second, constant speed, constant velocity. Okay, I'm going to call it the average velocity, because if it's constant, it's also the average. I have a time of 7 seconds, and I have an initial position. It says started at position of 5 meters. This is how you denote starting position. On your AP Physics 1 formula chart, it tells you X's position. The little subscript 0 means at time 0. So X at time 0, or starting X, basically, is 5 meters. The way that is read, though, I don't read X sub 0. I read it X naught. That's how you pronounce it. Okay, so X naught, if you hear me say X naught, that means that X sub 0. If you hear me say V naught, it means V sub 0. T naught, same thing. You'll see that little subscript 0 on here. It just means starting time, or starting position, or starting velocity. Okay, but that's how it's read. So that's what we have, and we're looking for final position. What is its final position? So what is X? The equation, this equation's not on my formula chart, but it's one that you should know. You guys know if I asked you, hey, what's the equation for speed? You would have told me distance over time. Well, velocity, we write that equation a little bit differently as displacement over time, but that's still what I have up here. And this equation's not on the formula chart, although I could derive it, and I can show you how to do that later. Yes, go ahead. Okay, so from here, we're going to look for final position. But right now, I don't even see final position. I see change in position. This delta, this Greek letter D, means change in. Hold on 1 second. Okay, so again, that delta means change in this case, change in position. You'll see delta X or delta V, change in velocity, delta T, change in time. Change in anything is always the final value minus the initial value. So final position minus initial position. How far am I from where I started? Okay, so I'm substituting that in. X minus X naught over T is my average velocity. Ultimately, I want to solve for this orange X. So I want to get it by itself. And I know that you guys might be used to plugging your numbers in here and then rearranging, but that's not what I'm going to do. And we'll explain why in a minute. I'm going to rearrange the variables instead and then substitute. So the first thing I need to do algebraically if I want to isolate this variable is get this denominator out of here. So I'm going to multiply both sides by t. That's going to cancel the time. And that's going to leave me with this. My average velocity times time equals x minus x naught. And now I just need to get that x by itself, and I can add x naught to both sides, and that leaves me with this. My final position equals my average velocity times time plus my initial position. Okay, so the reason I wanted to do this way is because in this course, I know this particular question I'm asking for a number answer. What is its position? Which I'm not done solving for it yet, obviously. Okay, but in this course, on your free response test, you will have a question that looks like math like this, except it doesn't give you any numbers. It says instead, hey, solve for final position in terms of velocity, time, initial position, and any constants. And you have to actually report your answer like that instead of actually solving for a number. So you have to get used to, if it's not something you're used to already, you have to get used to manipulating the variables before you put the numbers in. Okay? Because sometimes that's all it wants. It doesn't even care about a number. It wants to know, can you manipulate those variables? Can you derive a new equation? All right, so let's move on. Now that we have this, we're going to go ahead and solve, because this one actually does want a number. What is its final position? So we're going to substitute our numbers in. I have my 35 meters per second times my 7 seconds plus 5. Notice if you put the units in, you can even see where those cancel. Meters per second times seconds, those seconds cancel. And so I have 35 times 7 meters plus 5 more meters, which is 245 meters plus 5 more, or 250 meters would be your answer to this question. So again, be able to rearrange those equations and then put the numbers in. Now, if you want to put the numbers in first, I mean, I can't stop you from doing that. Just be aware that you're going to have questions later on that don't even want a number. They want you to give your answer as this equation instead, or as some other way more complicated one. Depends on the question. Any questions about this? Okay. So again, today I'm just talking about how to manipulate the equation. It doesn't have to be this equation, just any equation that you have. That's the first part of our notes and playlist 2 is math review. Tomorrow we're going to focus more on motion. But for now, for the rest of the class period today, you can work on playlist 2, which consists of the different task options that you see on my screen. These are the same ones. I just took a screenshot of your roadmap. So these are the same ones on your roadmap, but you have workbook practice, so 110 workbook practice, which is on paper, and some of you picked it up already, but some of you did not. It's on the front counter. 111 Physics Classroom is on the website, physicsclassroom.com, so there is no paper. Excuse me. 112 worksheet practice is in My Open Math. There is no paper. So the only one that's on physical paper is 110. So if you haven't picked that up yet, please do so. Your checkpoint this time is Dueling Dune Buggies. It is also in My Open Math. You have the rest of the period to work. If you have any questions, please let me know.